Hello everyone, my name's Paul. I work for a company called Micrographics in Cape Town, and we're an Autodesk reseller. We're going to do a series of 3 blogs based on a conversation with a client where we show the typical setup of a Revit file. Note, there are many different ways in which survey data can arrive on your desk, but this is a good way for you to handle a typical sort of setup. So first of all, let's have a look at an AutoCAD file that might be generated by a surveyor. In this case, we are going to have contours available to us on a contour layer, but it might just as well be other input data like a CSV file, but we will not be handling that today. So let's have a look at this AutoCAD file, understand what it is, and then bring it into a Revit file and set up a Revit file with the correct coordinates and generate a quick topography. Everything is set up for us here. In essence, we have some grid lines over here giving us an easting and a northing. It is at an angle to the global coordinate system within AutoCAD, but it isn't far away from the origin. Quite often that is a problem with survey files, but if you want to set up the Revit coordinate system, unless you have to interface directly with a Civil 3D published surface, which is seldom the case within a South African environment or Southern Hemisphere environment, you may put this close to the origin. So we have our easting and northings that are indicated in meters. And then we've got some contours with some elevations that are also indicated in meters. Note in this file that the file is set up to use millimeters in our units, and we can see we are using millimeters, and so we just need to input that into the Revit file when we insert this CAD file into Revit. The other thing to note is that the elevations have been lifted up into the correct elevation. If we have a look at the properties for this contour, which is essentially it's essentially just a polyline, and we want to see the properties. If we select this polyline, and there we can see it's at 1507,000. So in other words, it's in millimeters again. So each elevation is at the correct elevation. There we can see them. So the elevation or the contour layers are at the correct elevation, while we've got the easting and northings based on or at in the 0 XY plane, as well as some annotations and the outline of the site. All right, so that's essentially the AutoCAD file that we are dealing with. So when we do create the topography file, we could start a new project, say from a default metric. We would be on a site level. The site level is just a normal floor plan that's associated with level 1. And if we look at the view range, we can actually set that up to unlimited. Let's suppose you're operating in South Africa. There's very little chance that you'll be dealing with any sort of file that's higher than, say, 2 kilometers. So it's 2 kilometers. And then also we'll go unlimited in the Z direction. So we give us a good chance. We're slicing 2 kilometers above the sea level, and there we can see what that looks like, and we say okay. And that will now allow us to see pretty much everything that we are interested in. In addition to that, we've got the survey beacon and the project down there, the project base point. All right, so next step is we're going to insert. We are going to we can insert or link, but we can, in this case, I'm just going to link CAD because I don't want to have it available permanently. And I'll find the file that I'm looking for on the desktop there. Colors preserved, levels all, import units we can state explicitly as millimeters. We don't need to bother about correcting any lines, and we'll put it automatically origin to internal origin if we want, or otherwise we can just do manual origin and put it close to the center. Okay, and then correct lines that are slightly off axis. Oh, you know, just with the placement you can actually do auto center to center. That will tend to center the centroid of the AutoCAD file with the centroid of the of the Revit file, and then go OK. That now brings that file in. Obviously in this view we're currently looking at project north and true north being in exactly the same direction. The project north will only come in once we do an actual project, but in any case the project won't be based on this file, so whether we're in project north or true north doesn't really matter in this case. But what we do need to do is to rotate this file so that we've got the easting and the northing correctly set up. To do that, we can choose the place of rotation to somewhere close to the origin. We can choose on that line and turn it into a vertical, so that then gives us the the true north and orientation that we need there. Alright, so the next thing is that we need to input the coordinates. There we can see we've got 89, 100, and then decreasing 89, and then decreasing as we go to the right. So that will indicate to us that we are to the left of the survey beacon. In Revit we can only have a right-hand rectilinear coordinate system, so if our direction is increasing to the left even though it's positive values, then we need to input the coordinates as a negative in this case. So that we can do through the Manage tab, and we can then select the coordinates to specify coordinates at a point. We can select that line that we see there, and then we can input that as negative 89, 100, and then add 3 zeros to make that in millimeters. The result of that will be that if you report the shared coordinates from the line next to it, you'll find that it's 89 exactly, and that's exactly what we are looking for. In the other direction, we've got 84, 300 increasing to 84, 400. Again, it's increasing towards the bottom. In other words, we are to the bottom of the survey beacon, and again, we'll then input that value as a negative value. So we can publish we can set the coordinates, or specify the coordinates at point. We can select that line, and that's going to be negative 84, 300, and then 123. And then let's just report the coordinates at another line just to see if we are correct. Then we can see 84, 400. We are correct in this case. We've got our coordinates set up. What you'll see is that if you zoom to extents, let's save this file quickly. Let's just save the file save as project, and let's just put it over there. So leave it as project 2, that's fine. And here we can see, I'll just save it as let's call it the container file. File save as container file. File save as container. Okay, so there's our container file, and the last thing that we need to do here, two things that we can do is we can indicate that we've got topography, or we can generate the topography over there. It's quite easy. Let's go to a 3D view and show you what that looks like. So we've got these layers at the top there. Then we can go to our massing and site tools. There's the topo surface that we can set. We can create it from an import and select the link as an import, check none, and then select the contours as the element that you'd like to generate the topography from. Switching out into a shaded view, you can see where the topography was created. So that's now the topography for the file. So we've got the coordinate system set up. If you zoom extents on your site drawing, then you can see the survey beacon is all the way out there, and looking at the coordinate system over there, it says 0, 0, and then also an elevation of 0, which is correct. We want that survey beacon to be at sea level. We can hide that element so that we can easily zoom to the extents if we need. Alright, so then you can also input if you have drawn the property lines there, it's quite easy just to input those property lines here also with this tool. There's the property line that you can input. You can create by sketching. We know we've got those circles over there, so we can draw lines. Chain is on, and we use snap center SC just to snap into the center of those pegs. Whoops. There we go. Draw line, snap center, snap center. We just go around the property and make sure that we input the boundary line as required. Alright, so having done that, you're really done with the topography setup for this file for now. You can save that file and also remove the import if you want. Manage links. There's our CAD formats, and we can remove that link just to get rid of the CAD elements within the file. So maybe one thing that we could have done is to input the grid lines over there, just to give us a sense for the values that we've got there. What I normally do is I just name them based on the values that they represent. So that name I would put as 89 100 meters, something like that, and that would be 89 meters, and this is 88 900 meters, something like that, just to give us the sense of the size there. The grid lines 84 300 meters, and we've got 84 400 meters. So if we switch out into, say, 1:2000, we can see that very clearly, and that just gives us a sense of the of the eastings and the northings. And then also let's just get rid of the CAD. Yeah. So that's really the sort of short way of generating a topography file or a container file onto which you can now or which you can use to acquire the coordinates into other files. So you generally start, you might have some different sites around the world where you want to develop a design that you might have designed, and then this is the method of setting up that site file on which you want to host your design. In the next blog, we'll look at how to import this into another model, and then to acquire the coordinates from this file. And then on the last one, we will show how to bring that back into the model file. Now, you might wonder, into the container file, you might wonder why we are leaving the project base point at 0 over there. You don't necessarily need to do that, but in reality, what you could do is leave it somewhere on the site. So let's suppose that you had a very specific element on the site, or a point on the site where you want to leave that base point. Of course, you can do that. Let's just measure what is if we use the spot elevation, we want to have a spot elevation, say, over there somewhere. Then maybe we've got the peg or something that we can put there, 15038, and then we can just move this project base point. We can just move this project base point onto that point on the site. Of course, we might have multiple buildings on the site, so the project base point is not really common to all of the projects. So each project has its own base point, but we'd like to have this there at an elevation then of 150,3680, like that. Right, so looking at a 3D view at the visibility graphics overrides, if we switch on under the site heading the project base point, then we can see that project base point is somewhere on that site. Right, but like I said, because you might have different buildings on the site, unless you want to reference it to some other peg there, you don't really need that. So that's the first part of this exercise. In the next exercise, like I said, we'll look at then acquiring the coordinates from this file.